Hey BC Cal students, this video covers the related rates test that we took. For 1A, we need to find the rate of change of the volume, and we know the volume is 512, and the rate of change of a side is 1.5 square inches per second. So ds over dt equals 1.5, and v equals 512. The first thing we need to do is set 512 equal to the variable representation for volume, which is s cubed. And so if we take the cube root of both sides, we get 8 equals s. So then we come over and we have our volume equation, which is just s cubed. And I'm just going to say we did the derivative with respect to time. So we get dv over dt equals 3s squared ds over dt. And if we substitute in 8 for s, we get 3 times 8 squared times 1.5. 8 squared is 64. 64 times 3 is 192. And then 192 times 1.5. Basically we're adding 96 to this. That's going to give us 288 cubic inches per second. For letter B, we're finding the rate of change of the surface area. So we're going to say the surface area, I'm using an S for subscript for surface area. That is going to equal 6s squared because a cube has 6 sides and all of them are squares. So it's going to be 6s squared. Then if we take the derivative with respect to time, we would get dA over dt is equal to 12s ds over dt. And we substitute in 8 for s and 1.5 for ds over dt. And that's going to give us 96 times 1.5, which is the same as adding 96 and 48, which gives us 144 inches squared per second. For letter C, we want to find the rate of change of the long diagonal. So there are 2 diagonals in a cube. We'll say that we have a diagonal that goes across the base, and then what we're trying to find is this diagonal. So what we need to do is create a right triangle that involves this long diagonal. So to do that, the diagonal of the base is equal to the square root of s squared plus s squared, which is just root 2 times s. So we should remember from geometry and trigonometry that because a square has a right angle, the diagonal is going to bisect this and give us a 45, 45, 90 triangle. And the sides are s square root 2 for the hypotenuse of a 45, 45, 90 triangle. So if we want to find the length of this long diagonal, the one leg of this tall right triangle is s square root 2, the other side is s. So then we'll say the diagonal for the cube is, well, it's the square root of root 2s squared plus just s squared, which this is going to be 2s squared plus s squared, which is going to give us 3s squared under the square root. So that would leave us with root 3 times s. We need to relate, we want to find the rate of change of the long diagonal. So we can take the derivative of this with respect to time, and that would give us dc over dt equals root 3 ds over dt. And that's the square root of 3 times 1.5, which as a decimal, I did 15. 1.5 square root 3 is 2.6 equals 2.6 inches per second. So again, all we had to do was find a way to find the long diagonal, which again was just applying the Pythagorean theorem twice. For number 2, we have water is leaking from a sphere at a rate of 1/3 gallons per second. If 1 gallon is 231 cubic inches, we need to find the leak rate in cubic inches. So we'll say dV over dt is 1/3 times. So since it's leaking out, we'll just say it's negative 231 cubic inches. We'll just put that in at the end. So 231 divided by 3 is 77. So this equals negative 77 cubic inches per second. So what is the rate of change of the radius at the instant r equals 4? Well, for a sphere, volume is equal to 4/3 pi r cubed. And we know dV over dt from part A. So we're going to take the derivative with respect to time. That gives us dV over dt equals 3 times 4/3 is 4. So 4 pi r squared dr over dt. And since we have negative 77 equals, let's see, so r squared is going to be 16 times 4. That's going to be 64 pi dr over dt. And at this point, we would just do negative 77 divided by 64 pi, and we get negative 0.383. So negative 0.383 is it inches? Inches per second is dr over dt. And so then for part C, still using r equals 4, what is the rate of change of the surface of the water? So if we have a sphere, the surface is going to be a circle. So A equals just pi r squared. And if we take the derivative with respect to time, we're going to have dA over dt is 2 pi r dr over dt. And from part A, we know, from part B, we know dr over dt is negative 0.383, and we know r is 4. So we just have 2 times pi times 4 times negative 0.383. And that gives us 2 pi times, 4 times negative 0.383 is negative 9.62. Let's go with negative 9.63. So negative 9.63 inches squared per second. For number 3, we have the ladder question. A ladder is resting against a wall 10 feet above the ground. So if we draw our little picture, we'll draw a picture right here, for instance. So this is the side of the house. The ladder is 10 feet up the wall. And when the base of the ladder is 6 feet from the wall, it's sliding down at a rate of 0.75 feet per second. So this is 6. This rate is negative 0.75 feet per second. So negative 0.75 is equal to dy over dt. And for part A, we want to know the rate at which the base of the ladder is moving. So we need the Pythagorean theorem. Let's see. So we would get, well, I guess we can make this a constant. Doesn't really matter. We would have x squared plus y squared is equal to, So I actually didn't give you the length of the ladder. We can find this quickly. It is the square root of 136 because we do 10 squared plus 6 squared equals hypotenuse squared. So x squared plus y squared equals the square root of 136. When we take the derivative, we could have also put L squared, and since the rate of change of the ladder is 0, when we take the derivative, we would get 0 anyway. So we could either do a constant here or a constant in the derivative. It won't really matter. When we take the derivative with respect to time, we get 2x dx over dt plus 2y dy over dt equals 0. And again, that would be the same as if we did x squared plus y squared equals L squared, and the derivative is 2x dx over dt plus 2y dy over dt equals 2L dl over dt. And since the latter doesn't change length over time, this side would be 0 because dl over dt would be 0. So we effectively get the same thing. When we substitute in x is 6, so we have 2 times 6 times dx over dt plus 2 times y is 10 times negative 0.75. Negative 0.75 equals 0. So let's see, that's going to be 12 dx over dt equals that is 7.5 times, well, so it's just 20 times negative 0.75, which is negative 15. So when we add 15 to the other side, we get dx over dt. 12 dx over dt equals 15. So that's going to imply that dx over dt is 15 over 12 is, was it 1.25? Let's check that. Yeah, it's 1.25. So 1.25 inches, feet per second. Now again, it makes sense that this value is positive because if the ladder is moving, if the ladder is sliding down, the base is moving forward. So we should get a positive value. For letter B, at what rate is the angle between the ladder and the ground changing? So the ladder and the ground is going to be this angle theta. I would use just use sine for this. So we know that sine theta is going to equal y over the length of the ladder. Now again, we know the length of the ladder is is the square root of 136. So sine theta is y over root 136. If we take the derivative with respect to time, we get cosine theta. We apply the chain rule, we get d theta over dt equals this y over root 136 is just 1 over root 36 times y. And so when you take the derivative, you just have 1 over root 136 dy over dt. And looking at the diagram, we know that when x is 6, y is 10, cosine theta is just 6 over root 136. So we have 6 over root 136 d theta over dt equals 1 over root 136 dy over dt. And we know dy over dt is, what was it, negative 0.75. So if we simplify this, we get d theta over dt. If we multiply by the reciprocal, we're going to have d theta over dt equals 1/6, because if we multiply by root 136 over 6, it would cancel out on the right side and leave us with a 6 in the denominator. So that's going to be 1/6 times negative 0.75. And that is, let's see. So negative 0.75 times 1/6 is negative 0.125. So negative 0.125 radians per second. And again, it makes sense that the angle should be getting smaller because if the ladder is sliding down, the angle should get smaller. And then finally for part C, at what rate is the area of the triangle made by the ladder and the ground and the wall changing? So if we look at part B, the area is going to equal 1/2 x times y. So we get A equals 1/2. We're just going to do the product x, y in parentheses. So if we take the derivative with respect to time, we get dA over dt equals 1/2. And we're just going to distribute the half to the product rule. So x times dy over dt plus y times dx over dt. And we substitute in all the values that we have. X is 6, dy over dt was negative 0.75. Y was equal to 10, and dx over dt was 1.25. So since we have a calculator, we can just do 0.5 times 6 times negative 0.75 plus 10 times 1.25, close parentheses, and we get 4 square inches, square feet per second, square feet per second. So 4 square feet per second. And for the final problems on the last page, we have a conical tank is water is evaporating from the tank. We have this relationship where the maximum height is 10, h is whatever, and the diameter is 10. So that means that the diameter is 10. We know that r equals 5. So if r equals 5, then the relationship that we have is r over h is equal to 5 over 10, which gives us two different equations. One is that r equals 1/2 h, and the other is that h equals 2r. So for part A, we have to find the rate of change of the volume with respect to time when h equals 6. Let's see, so V equals for a cone 1/3 pi r squared times h. The derivative, now we could like take the derivative and do the product rule, and we would get a perfectly fine answer. It is much easier to replace either r or h, so we don't have to do that. If we replace h with 2r, for instance, we can get v equals, if h is 2r, we would have 2r cubed times pi times 1/3. So we'll say 2/3 pi r cubed. And so when h, we want to find a rate of change of the volume when h is 6. So if h is 6, it means that r equals 3. So when we take the derivative with respect to time, we get dv over dt equals 2 pi r squared dr over dt. So we have to find a rate of change. So first we need to find, so I guess it would have made more sense. So we were told that the height is changing at a rate of 5/8 centimeters per hour. Well, we can just still use that. So over here, if h equals 2r, dh over dt is 2 dr over dt. And since we already have this derivative with r's involved, we can have, let's see, that's 5/8 equals 2 dr over dt. So we divide both sides by 2, and we would get 5/16 is dr over dt. So we get the same thing. So we would have 2 pi, r is going to be 3, so that's going to be 9 times dr over dt is 5/16. If we put all this in the calculator, that's going to be 2 times 9 times pi divided by 16. Oh, and times 5, then divided by 16 is 17.67. So is 17.67 what volume? So it's cubic centimeters per hour. We have to find the rate of change of the radius with respect to time. I feel like we already did that right here. We had 5/16 dr over dt. For number 5, a circle is inscribed in a square as shown to the right. The circumference of the circle is increasing at a rate of 14 inches per second, while the square expands to maintain tangency. So let's see. We know the formula for circumference is c equals 2 pi times the radius. So this is the radius of the square. This is a radius of the circle. So that means that we have the relationship that the side of a square is s is going to equal 2 times the radius. That'll be handy in a moment. So when we take the derivative, we get dc over dt equals 2 pi dr over dt. And since we know the rate of change of the circumference is 14, we would have 14 equals 2 pi dr over dt, and 14 divided by 2 pi is 14 divided by 2 pi gives us 2.23. So 2.23 is equal to dr over dt. And since we have the relationship s equals 2r, ds over dt is 2 dr over dt, which means ds over dt is just 2 times this, which is 4.46. And so since we still haven't gotten to the perimeter. The perimeter of a square is just 4s, and so dp over dt is 4ds over dt, which is going to be 4 times 4.46, which is 4 times 4 is 16. 4 times 0.46 is 1.84. I think it's 17.84. 4 times 4.46, 17.84. So 17.84 units are inches per second. For part B, what is the rate of change of the area inside the square but outside of the circle? Well, we'll say the net area of this shape is the area of a square, which is s squared, minus the area of the circle, which is pi r squared. Now, it would be helpful to get rid of the s. We already have the relationship s equals 2r. So the area is actually 4r squared minus pi r squared, which if we notice, that's 4 minus pi times r squared. We can just factor out an r squared. And the derivative with respect to time is dA over dt equals 2 times 4 minus pi times r times dr over dt. So we can assume that r is still 3 because that's the information that we were given. So then we would just have 2 times 4 minus pi times 3, and dr over dt was 2.23. And whatever that gives us, so 2 times 4 minus pi times 3 times 2.23 is 11.49. So that is equal to 11.49 square inches per second. All right, so that concludes this video over this quiz. Hopefully you guys understand, can do the corrections. If not, please talk to me in class.